Hello everyone, I'm Yang Yan from China. I'm sorry that I haven't got my visa until now, so I have to attend the workshop this way. I hope you don't mind. I work for Datang Environment Industry Group located in Beijing. Our company is mainly focused on environmental protection related to thermal power plants, and my work is mainly research and development of new wastewater treatment technologies for the plants. Today, the title of my presentation is A Case of Treatment and Resource Utilization of High Saline Wastewater. And this is the outline. First, background. Second, a new process for treating high saline wastewater in thermal power plants, namely SAP, NF, RO, and BMED process. Third, I will introduce the advantages and application scenarios of this process. Sources of high saline wastewater are extensive, including power industry, coal chemical industry, textile, printing, and dyeing industry. The hazards of high saline wastewater mainly include pollution of surface waters and groundwater, destruction of ecosystem, salinization of soil, and so on. Here is a traditional wastewater treatment route for desulfurization wastewater in thermal power plants. After pre-treatment, desulfurization wastewater would be concentrated, and part of the water is reused. The reduced wastewater enters the solidification process, and the waste salt is treated as pollutants. Here is the new way of desulfurization wastewater treatment developed by our company, namely SAP, NF, RO, BMED process. SAP stands for sulfate assistant precipitation. NF is nanofiltration. RO is reverse osmosis. BMED is bipolar membrane electrodialysis. This is the overall route. We use SAP and NF for pretreatment, RO for concentration. Finally, we get fresh water, sodium hydroxide, and hydrochloric acid from BMED for reuse. Next, let me introduce each part separately. For the SAP and NF part, we use calcium hydroxide and sodium sulfate instead of sodium hydroxide and sodium carbonate to remove calcium and magnesium. The cost can be reduced by more than 50%. And then, after nanofiltration, we get concentrated water of sodium chloride. About SAP process, these are photos of our pilot test in a thermal power plant. After SAP process, magnesium dropped from 3,000 milligram per liter to less than 5. Calcium dropped from about 1,000 milligram per liter to less than 3. These are photos of nanofiltration. The efficiency of salt separation by nanofiltration reached 99%. The concentration of sulfate in concentrated water can reach 20,000 milligram per liter, which meets the requirements of the SAP reuse. Here is a photo of nanofiltration equipment. A 6 to 7% sodium chloride solution is produced, which meets the requirement of bipolar membrane electrodialysis. These are sketch pictures of BMED. A membrane stack includes two bipolar membranes with a cationic membrane and an anionic membrane in the middle. Bipolar membrane can electrolyze water molecules into hydrogen ions and hydroxide ions. After sodium chloride enters the equipment, sodium ions in the solution pass through the cationic membrane and combine with hydroxide ions to form sodium hydroxide, and chloride ions pass through the anionic membrane and combine with hydrogen ions to form hydrochloric acid, so that we can reuse the acid and alkali. Here is a photo of BMED we used at the site of the thermal power plant. The circulating volume is 600 to 1000 liter per hour. Yield is 2 kilogram per hour. This is a picture of water samples, including raw water, fresh water, acid, and alkali. After the equipment is started about 83 minutes, the concentration of alkali and acid can be stabilized at 5 to 6%. Impurities in acid and alkali are less than 0.5%, which can fully meet the requirement of reuse. Finally, let me summarize the advantages of this process. First, high product value. It's suitable for enterprises with high acid and alkali consumption. Second, extensive use. It can be widely used in steel, metallurgy, power, and other industries. Third, low cost. The cost can be reduced by more than 50% in the softening process. When applying this process, the following requirements should also be met. The concentration of influent sodium chloride is more than 1%, and there is little organic matter in the wastewater. So, this is my presentation, and I hope it is helpful. Thank you very much for your listening.